Okay, the next topic is errors in measurement. Error is nothing but the difference between the measured value and the true value. The difference between the measured value, the value which we are measured on a particular element, and the standard value is called as error. It is the difference between the measured value and the true value of the measured dimension. It is never possible to measure the true value of a dimension. There is always some error, and the error in measurement may be expressed or evaluated as an absolute error. It may be expressed or evaluated either as an absolute error or an relative error. Then what is maybe absolute error? It is the distance between the measured value and the true value of the quantity measured. It is the distance between the measured value. Measured value means is nothing but the value which we got the measurement for the particular element or the measured element and the true value of the quantity to be measured. Okay, there are two different types of absolute error. One is true absolute error, another one is apparent absolute error. It is the difference, algebraic difference between the result of measurement and conventional true value of the measurement is known as true absolute error. The algebraic difference between the measured value and the conventional true value of the quantity is called as true absolute error. Then what is the apparent absolute error? It is nothing but the algebraic if we find out the value of a particular element and get the value of a series of measurements, then we took one value from the result and the arithmetic mean of all the results, and we should find out we should get some difference between the algebraic difference of a particular value and the arithmetic mean value is known as apparent absolute error. It is the algebraic difference between one of the results in the series of measurement and arithmetic mean of series of measurement is known as apparent absolute error. Apparent absolute error. Then what is the relative error? It is nothing but there is a ratio between the absolute error and the measured value. The relative error is a ratio between the absolute error and the measured value. So we know what is maybe absolute error. It is a comparison between, or the value of comparison may be the true value and the conventional true value, or the arithmetic mean of series of measurement is known as absolute error. So the error depends upon some factors. The relative error depends upon some factors. It may be the calibration standard should be changed. The calibration standard change, if the calibration standard change, the relative error occurs. Then there's a problem in the workpiece or an element. There's a problem in the workpiece or an element, the relative error may occur. And if the workpiece, and the instrument, if in the instrument, if there is any deviations or any problems, the relative error may occur. And person's error means it is nothing but the observational or recorded error. While he observed the value or while recording the value, he may put some errors or deviations. And environment, while we take the measurement, the environment, if the environment changes, the relative error may occur. Then the different types of errors. Normally the errors are classified into three categories. One is gross error, systematic error and random error. Gross error, systematic error and random error. In systematic error, there are three types of errors. One is instrumental error, observational error, and environmental error. Next one is gross error. Gross error is also called as parasitic errors. Gross error is also called as parasitic errors. These errors varies in an unpredictable manner. This error, we can't predict this type of errors. It always occur in an unpredictable manner. These errors mainly covers the human mistakes in readings, recording, and calculating measurement results. While with the humans or the observers, while they take the readings and record that readings and calculating the measuring or putting some calculations, they may did some mistakes. So we call it as also a gross error, and it occurs due to the fault of the person using the instrument. The observer or the operator make some fault in while they take the reading on a particular device. That is called as gross error. Some of the examples of gross error are incorrect reading, incorrect recording, and incorrect use of instruments. Then how we can avoid these type of errors? These type of errors can avoided by the greater care must be taken in reading and recording the data. While the operator get the readings from the particular element or particular operation, they should take more care while they take the reading and recording the data. While we take a reading, if we can't satisfy on a particular reading, we should take two, three or more type readings taken for the particular quantity under the measurement. That is called as in that way we can avoid the gross errors. Then systematic errors. Error in instrument or in the design of instrument. Systematic error is nothing but the error which may occurs in the instrument or design of the experiment. Sometimes the instrument make some errors while we take the readings, or the design of the experiment. While we design the experiment process, we make some errors. That is called as the systematic error. It cannot be estimated by repeating the experiment with the same equipment. If the instrument makes that errors, we can't able to repeat the experiment with the same equipment. We have to change the equipment to find out the output. The causes of these errors may be known or unknown. These systematic errors may cause with a known error or the unknown process. We can't able to find out that how the error came or how the error occurs. These error may be constant or variable. In this systematic error, the errors may be constantly maintain that error, or it may be vary. And these errors are repetitive in nature. Types of systematic errors: there are static error and dynamic error. Two types of systematic errors are there. One is static error and dynamic error. Then what is the static error? It is caused various components in a measuring device. This static error caused in a various components. While we using in a measuring device, various components are used in this particular measuring device. For that purpose, these errors may occur. Then environmental effects and other properties which influence the apparatus are also the reason for static error. The environmental effects, the surrounding may also give some error in the apparatus, and other properties also influence the apparatus, so that this static error may occur. Then dynamic error. This dynamic error, the instrument is not responding very fast enough to follow the changes in the measured variable. In the measured variable, the measured variable is changed in a fast manner, but the system will not follow the changes in the measured element. It is caused due to time variation in the measurements. These elements or this error may cause due to the time variations in a particular measurement. Then types of systematic error. There are different types of systematic errors are there. One is instrumental error, observational error, and environmental error. Then what is the main instrumental error? This error due to the fault of the particular instrument. This error normally occurs on the particular instrument, so that we can't able to find out the accurate value, but the error may occur every time while using this fault instrument. Some instrumental errors may occur due to the friction in bearings, then in the instrument's moving components, then the instrument's irregular spring tension, then stretching of spring stretching may also some error occurs, and overloading of the instrument. Overloading of the instrument means some external elements we may use in this particular instrument, so that the instrument may get overloaded and causes the errors. Okay, how we can avoid the instrumental errors? To avoid the instrumental error, we should select the suitable instrument for the particular measuring element. We should select the suitable instrument for the particular measuring element and applying correction factor after determination of instrumental errors. After we find out the instrumental determination of instrumental for instrumental error, we should applying the correction factor. We know due to this instrument the error may occur, so we have to apply the correction factor. We have to change the instrument and find out the value. Then calibrate the instrument against the standard. We should calibrate instrument time to time to get the accurate value. Then observational error. These errors are done by the observers. Observers are nothing but the operators or the reading takers. The types of observational errors are reading error, parallax error, interpolation error. Reading error is nothing but indication of an instrument by the observer, which means the instrument indicate one value, but the observer noted another value. Incorrect reading of the indication of an instrument by the observer. The observer which noted the incorrect value which indicates by the instrument. Okay. Then parallax error. The parallax error is nothing but the reading is not made in the direction of observation. Parallax error is nothing but we have to note the value in a straight direction, but sometimes we note the value in an angular direction. These kind of wrong aspects, we get the wrong value. Then the last one is interpolation error. Inexact evaluation of the position of the index. It is called as inexact evaluation. While we evaluate the output of the value or the measured output, we can't get the exact value, but we get the value as a adjacent value. The instrument shows one value, but we took or record the adjacent value of that particular value. Then environmental error. This environmental error occurs due to external conditions to the measuring device or measuring element. It may cause by the temperature, humidity, air or pressure, dust or vibrations on the particular instrument. We can eliminate this environmental error by maintaining proper atmospheric conditions using the air conditioner or magnetic shields. Calibration of the instrument at the place of use. The particular place should maintain a proper surface, or the instrument should be in a calibrated manner. Sealing certain components in the instruments. In the instrument, we should lock the components on a particular manner. Then automatic devices are used to compensate the effects. Some automatic devices we should use to compensate the surrounding effects. That is called as in these conditions we should eliminate the environmental error. Then random error. A random error is nothing but it may cause and they occur when all the systematic errors have been accounted. All the systematic errors have been accounted to cause these type of random errors. These errors caused by the factors randomly affect the measurement, the variable across the sample. It may cause sudden change in the conditions or noise and tiredness of the working persons. Maybe it is a positive error or a negative error. We can avoid these random errors increasing the number of readings process and statistical means to obtain the best approximate value. We should getting the statistical of the number of readings and get the approximate true value. Then the different types of sources or causes of error. The next topic is sources or causes of errors. The different causes of errors are errors due to deflection, then misalignment, contact pressure or stylus pressure, then poor contact, vibrations, dirt, wear in gauges, looseness, parallax effect. Errors due to deflection. They get deformed or deflected on a long boss. While we get the long boss measurement, it may get deformed or deflected while we taking the measurement, so that we get the error in a particular conditions. Then misalignment. Errors due to misalignment. The axis of the measurement of the measured part should coincide with the axis of the measurement of the measuring instrument. Then only we can avoid this misalignment. If the alignment is not in a proper manner, the error may occur on a particular element. Then contact pressure or stylus pressure. The variations in the contact pressure between anvils of the instrument and workpiece being measured produce a considerable difference in reading. The deformation of the workpiece and stylus of instrument depend upon the contact pressure and shape of the contact surfaces. Then due to poor contact. To avoid this type of errors, the gauges with a lesser area of contact should be used while measuring irregular a curved surface, and correct pressure should be applied while making the contact. Contact of jaws with workpiece plays an important role in a measurement in a laboratory or workshops. Then errors due to vibrations. Errors due to vibrations can be avoided by the following measures. Following some of the measures locating the laboratory away from the sources of vibrations. If we locate the laboratory away from the sources of vibrations, then only we can avoid this vibration error. Then keeping slipping cork, felt rubber pads under the gauge. We should keep this cork, slipping cork, then rubber pads, then felt under the gauge means we can reduce this vibrations. Then mounting the gauge pedestal and floor sections on a tar resin. We should mount the gauge pedestal and the floor sections on the tar resin, then only we can avoid the vibrations. Putting a gauge on a surface plate, resting in turn on a heavy plate. Then by using these conditions, we can avoid the vibrations. Then avoid error due to dirt. We should avoid this dirt to reduce the error. Dirt particles can enter the inspection room through the door and the windows. If these foreign matters such as dirt, chips, etc. are present between datum and workpiece surface, the error will be introduced in the reading checker. Then errors due to wear gauges. Wear of measuring surfaces of the instrument occurs due to repeated use. These type of errors can be avoided by hardening the surface by using the chrome plated parts for contact surfaces. Then errors due to looseness. The looseness can be tested by setting the gauge contact on a gauge anvil and zeroing the meter and then applying the finger pressure or a light tab to each location where looseness might be expected and note the readings again. We should tighten the loosed object or product, then only we can find out the proper output. Then error due to parallax effects. Error due to parallax effect. It is a reading error which is produced when with the index at a certain distance from a surface of scale. The reading is not made in the direction of observation provided for the instrument use. So the parallax error which occurs in a wrong way of getting the output. So we should always maintain the correct view on a instrument and find out the value. We can reduce these type of errors by separating between the scale and a pointer to a minimum and placing a mirror behind the pointer to ensure normal reading of the scale in all cases. This is called as parallax effect. Due to parallax effect, the errors may occur. Okay, now the last topic is types of standards. What is meant by standard? Standard is nothing but it is a reference for assigning a numerical value to a measured quantity. Already we studied so many times what is meant by standard. Now again we have studied standard elaborately. It is a reference value to a measured quantity or a reference value which we are going to compare with the measured quantity. That is called standard. Then there are two standards are followed for linear measurement. One is British or English yard, another one is metric or meter standard. There are two different standards are followed for the linear measurement. One is British or English standard, English yard, and another one is metric or meter standard. Then this metric or meter standard is followed by most of the countries in the world. Normally this standard metric or meter standard is followed by most of the countries all over the world. Yard is followed by some of the countries only, but most of the countries follow this metric or meter standard. Then what are the types of standard? Normally we are calculate the measurement, linear measurement. This linear measurement classify the types of standards. The types of standards are line standard, end standard and wavelength standard. The types of standards are line standard, end standard and wavelength standard. Now we are going to see what is meant by line standard. When the length being measured is expressed as the distance between two engraved lines, then it is called as line standard. Distance between two engraved lines is called as line standard. Examples: measuring scales, imperial standard yard, international prototype meter, etc. What is meant by engraved? This engraved line means it may be done with the help of some scriber on a surface or any pencil on the surface or any point on the surface. Pointing line is on the surface. These are called engraved lines. the distance between the two engraved lines, some scratches on the surface between the two scratched surfaces is called as line standard. The figure also we can see that distance between the two engraved lines, some scratches on the square surface, some scratches or end may be reference between the two distances is called as line standard. The distance between the two reference line, it may be also called as a reference line or engraved lines, is called as line standards. Then end standard. What is meant by end standard? When the length being measured is expressed as the distance between two parallel surfaces. The distance between the two parallel surfaces is called end standard. It can be made to a very high degree of accuracy. Example, slip gauges, gap gauges, end of micrometer anvils, etc. The distance between the two parallel surfaces is called end standard. Normally these end standards are we can see in the slip gauges or in the micrometer anvils. There are two parallel surfaces. That is called end standard. Wavelength standard. In order to overcome the drawbacks of line standard and end standard, it became necessary to have a standard which will be accurate and invariable. To overcome the drawbacks of the line standard and end standard, the standard which will be accurate and invariable. Invariable means it cannot be variable. It cannot be variable and it should be always accurate. So for that purpose we are going for the wavelength standard. Wavelength of monochromatic light can be used as natural and invariable unit. With the help of wavelength of a monochromatic light source, we can able to find out the length which is an invariable unit. That is called wavelength standard. Then subdivision of standards. The standards of measurement can be classified as 4 different standards. One is international standard, second one is primary standard, third one is secondary standard, fourth one is working or territory standard. First one, international standard. This standard is defined by the international agreement. They are maintained at the International Bureau of Weight and Measure in France. These international standards is followed by the all over the world international level. These standards are followed all over the world internationally, and these standards may get started from the research laboratory or followed by the standards from the France. They have the International Bureau for the Weight and Measure, which can be created to the international level standards. This international level standards periodically evaluated and checked by absolute measurements in terms of fundamental units. These measurements are evaluated periodically and checked by the absolute measurements in the fundamental units. The certain units of measurement to the closest possible accuracy attainable by the science of technology. Attainable by the science of technology. These are called international standards. Then primary standards. It is only one material standard and it is preserved under the most careful conditions. These primary standards followed for the only one material For each and every material, they follow some standards. So, we should preserve this type of standards under very careful conditions. For each and every standards, each and every material, the standards will be variable. So it is maintained at the National Standard Laboratory in different countries. In different countries, these primary standards are used and it is maintained at the National Standard Laboratory. For in India, in New Delhi, the National Physical Laboratory is there. They are followed the National Physical Laboratory is there. They are followed the primary standards. These standards are very accurate and it is scientifically possible to achieve. These standards are very accurate and scientifically we can possible to achieve that accurate value. It is not available for the outside the national laboratory. These primary standards are not available outside the national laboratories. And next one is secondary standards. These standards are the basic reference for the calibration laboratories and industries. They are used for comparison with the working standards. These secondary standards are the reference for all the calibration laboratories and industries for the comparison with the working standards. Each industry has its own secondary standard. For each and every industry, they can produce their own standards, secondary standards. Each laboratory, in each industry, each laboratory periodically sends a secondary standard to the national standard laboratories. In each industry, from their laboratory, periodically sends their secondary standard level to the national standard laboratories for the calibration and comparison with the primary standards. After the comparison and calibration at the national standard laboratories, the secondary standards to the particular industry laboratory with a certification of measuring accuracy in terms of primary standards. After from each and every industry, there is a laboratory for secondary standards. From that laboratory, they are sending the secondary standards to the national standard laboratory for the comparison and calibration with the primary standards. After comparison and calibration, the national standard laboratory returns the secondary standards to the particular company with the certification of measuring accuracy in terms of primary standards. And the last one is working or territory standards. These are the main tools of measuring laboratory. Working standard or territory standards are the main tools of a measuring laboratory. These standards are used to check and calibrate laboratory instrument for accuracy and performance. These working standards or territory standards are used to check and evaluate and calibrate the measuring instruments time to time for their accuracy and performance improvement. For example, plug gauge is used for checking the bore diameter of bearings. So these are the working or territory standards. By this, the first unit comes to the end. Thank you.